Hello! In this video we will talk about the new module which supports disinfection with the ultraviolet. Ultraviolet is used for disinfection and other purposes, but C-19 pandemic highly increased the demand for all types of disinfection. Use cases of UV applicability have expanded so much that traditional sources like mercury lamps are not enough anymore. More efficient and more expensive sources of ultraviolet are diodes of UVC spectrum. UVC spectrum is more efficient in terms of antibacterial effect. More information about UV sources can be found in an article linked in the description. This specific video covers specific UVC module. This is a ClimateGuard board with the 6 diodes and 4 distribution pins, which are used for power supply connection and control. Connectors located at module edges allow combining up to 9 boards into a cluster with a single power supply point. There are 3 operational pins on the board. Other 2 pins made for secure fastening of modules. First pin is a power supply one with a circuit from 3.3 to 5 volts. Boost converter or step-up converter located on the board ensures stable operation for entire circuit range. And by the way, the circuit range generated from lithium battery perfectly fits for modules supplied directly without step-up converter. Rightmost contact is a ground, the middle one is a control pin, and the module equipped with a transistor controlled by logic signal voltage levels. To prevent pin burnout during clustering, each module's control pins except the power supply one has voltage output switched by the transistor. In other words, control pins are not directly connected. If you are going to power your module directly from battery or from, let's say, USB port, you can just close the circuit on the control pin. Now, let's talk about how efficient our device is. Diode lens has angle of 120 degrees. So let's assume that the entire board is one large diode. Then, based on the geometry, area of a light spot is equal to 9.5 h squared, where h is the distance between diode and irradiated surface. Measured electrical current is 0.03 ampere, which according to diode datasheet should generate 5 mW of UVC radiation. According to 6 diodes, will produce 30 mW of UVC radiation. Now let's say we want to have a device which will disinfect the surface from 5 cm distance. For example, module attached 5 cm above the door handle. So the area of irradiated surface will be 240 squared centimeters, which gives us a radiation density of 1.25 watt per square meter. This is the dose that kills 90% of all viruses, which is equal to 67 joules per square meter. Double dose kills 99, and triple dose kills 99.9% of viruses, and so on. So surface under the module will get such radiation dose in approximately 45 to 54 seconds. Of course, this is more like a qualitative analysis with some number of assumptions, so the real picture might be slightly different. For example, radiation density in the center of light spot will be higher than on edges, so the disinfection in the center will be more efficient. 54 seconds is not an ideal result, but that's why ClimateGuard module supports clustering. Let's say cluster of 3 modules will disinfect your smartphone in 17 seconds. There are a lot of different use cases, like embedding into different devices and local disinfection, but my use case as an example is a disinfection power bank. So please leave a comment in case of any questions, and thanks for watching.